Well, you got for 30%. Let's try it again.
So these are obviously different because they're not arithmetic. So we did have some conversations about these, and we talked about, I think the word came up that um, this is a type of sequence where the numbers are being multiplied to get each other, not added. So yeah, so if you see something that's like times two, so um, bless you. So if you have like a 5 and then your next term is a 10 and then your next term is a 20 and then your next term is a 40. So like we could write this down just as an example. So let's say you had like 5 and then a 10 and then a 20 and then a 40 and then an 80 dot dot dot. You can clearly see that this isn't arithmetic because if we tried to do plus, it would go plus 5, plus 10, plus 20, plus 40. But you can see that it's times 2. And so, yeah, double. So since we're multiplying by 2 and then multiplying by 2 and then multiplying by 2, a consistent pattern of multiplication by the exact same number tells us that this is a geometric sequence. And one of the things you'll be asked for in the assignment today is what's called a common ratio. And so the common ratio, I'm going to write this down. You don't always have to write when you do like your assignment or take a quiz. You don't have to write the words common ratio, but I want you to know what it means in the instructions. The letter that we use for common ratio is R, lowercase r, please. And lowercase r stands for ratio. And the ratio in this case is simply 2. It's what you're multiplying by each time you go from term to term, right? So if I asked you to find, say, like the next 3 terms of this sequence, you wouldn't have any issues with that at all because you could just continue the pattern, right? So if I asked you to find the next term, it would be double, so 160, and then double, so 320, and then double, and so on and so forth. So that's kind of the basic of what a geometric sequence is. It's just multiplied by the same number each time instead of added or subtracted. Sound good? Okay, so where we run into trouble is, again, of course, it's all fine and dandy. Like anyone can look right at this and see this is the first term, this is the second term, third term formula. Yep, that's where we're headed. So again, anyone can see the first, second, third, fourth, fifth, but where we run into trouble is like, what's the 20th term, right? And that becomes difficult if we don't feel like we want to write all of the first 20 out. So this is where the formulas are going to come into play. And so just like with arithmetic, you're going to have 2 types of formulas. You're going to have an explicit formula, and you're going to have a recursive formula. So I had made myself a note card and just said, you know what, I'm going to be real direct about this and tell you just straight up how the formulas look. And you definitely would be nuts to not write this part down. So first off, let's talk about the explicit formula. And remember that the explicit formula is the one that you can use to just find anything that someone asks you to find. The recursive formula isn't so useful. It's like if I said find the 30th term, the recursive formula makes it a little bit harder. But the explicit formula is a nice direct route to just say, you want the 30th term? Give me a formula and I'll plug 30 in place of n and just call it a day. Like it's as easy as math gets. So the explicit formula for an arithmetic sequence looks like this. I'll write it in green for you. It says that any term a sub n can be found by taking a sub 1. And what is a sub 1 again? What does that mean?
The first term.
So you take the first term and you multiply it by the common ratio r raised to the power of n minus 1. And there's going to come a point where you will just literally understand what that means. Like you'll understand how it works. I could try to brute force it into you, but at some point you just understand that it just makes sense that you have what you start with, and then you keep multiplying it by the common ratio a given number of times. And if you're wondering why there's an n minus 1 up here, it's because the first term doesn't count, basically. Yeah. So like if the first term in this sequence is 5, I don't have to make any jumps to get to 5, right? So if I think about it as the first term, if you put 1 right there in place of n, what's 1 minus 1? And so that's why you don't have to make jumps. And so by putting n minus 1 in that explicit formula, you're saying you don't have to do any math to get the first term. He's just there, right? So anyways, that's what the explicit formula looks like. And you definitely want to have that just like that, boom, right in your notes. Because you're going to be asked to do that on every problem today. Find the explicit and also find the recursive. Thank you for that. So let's use this example up at the top. So using the explicit formula, I hope I can sales pitch you on this. It's really, really easy. So if I said to you that I want you to find the 12th term, and honestly, you could make a case at this point that it might be quicker just to keep writing the next terms, because like we're already at 8. So you could just do 4 more, but that's really not where I want to go with this conversation. So if I said to find the 12th term, then all I simply have to do is replace this n up here with the number 12.
You replace R?
We will replace r with what? No, yes, in this case 2, because the common ratio is times 2. And then what will we replace a sub 1 with? Which is 5. Good job, guys. So all the letters when we use an explicit formula can become numbers. So like in our case, if we were going to do the 12th term, we would say, okay, here we go. It's going to be 5 times 2 to the power of what? Yep, to the power of 11. 12 minus 1 is 11. No, the sub 1 was just a label to tell us what to put there. So a sub 1 is like a variable, and we just replace it with the first term 5. Got it? And then your calculator is certainly going to be an essential part of today. A lot of the answers are in the millions, literally in the millions. So if I type in 5 times 2 to the power of 11, I personally got 10,240. So you want to practice on your calculator, make sure you understand how to do that. Because I think that on the TI calculators, I got 10,240. Jason, let's see. And it's not plus, okay? It's times. Hi, Lucas, by the way. So you want to do 5 times 2, and then it's this little caret right here.
Yeah.
That's your power. So hit that, and then type in 11. That's your power button, and then you should get 10,240. Is that a match? Elton, did you get that? You got it now? You're good? Eli, did you get it?
Yeah, I did.
Okay, and Jace, you're good. Great. So that's how you use an explicit formula. It's very, 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 very simple. And it's very literal. Like there's no hijinks, no shenanigans. You just replace the n with whatever someone asks. And all the other numbers you'll know because you can literally with your eyes see the first term. And then you'll have to do a little bit of basic math to figure out the r, but that's pretty easy. So I think that's pretty hard to make a difficult situation out of that. The next thing we have to talk about is how to write this will never be difficult today, for the record. This lesson never gets hard, I don't think. So the next thing we have to talk about is the recursive formula. So I'm trying to do a little bit better job with this than I did on the arithmetic. So just giving you what you need, kind of one-stop shopping here. So the recursive formula, I'll switch colors here and use yellow. The recursive formula says that any term, and this actually, this will make sense. Like I'm 99% sure that you'll look at it and go, oh, that's obvious. The recursive formula says basically that any term is equal to the term that came before it times r. Okay. I mean, that just ought to click. I mean, think about it. Like, do we all agree, if you look up here, isn't the third term just the second term times r times 2? Isn't the 6th term just the 5th term times r? So that recursive formula is actually super easy with, it's so much easier with geometrics than it was with arithmetics, because it's almost like, how can you not see that? Well, of course, that's what it is. So that's what our recursive formula is. And so there they are right there. You're going to definitely use the dickens out of those today as you go through the worksheet. So what I want to do is run through basically a problem with you. Oh, and I'm sorry for this. And how dare I? I forgot that part of the recursive formula, I'm so sorry, is also, of course, saying what the first term is. That I took that for granted because, well, we have it on the board. But we also have to say like a sub 1 is 5. My bad. So you want to fix that. Apologies. Your recursive formula, whether it's arithmetic or geometric, always has to have one term given, and we just generally just give the first term. So, but without that, then the recursive would do you no good because you don't know like where to start. So,
How do you go backwards? Like, what if they give you the 10th time? Like,
it's a really smart question. Yeah, you can. As long as you know what R is, then you can backtrack. So like if you knew in a case like this that the 10th term was 2,560, which it is, then you could go backwards and divide by 2, divide, and you can do that 9 times back to the beginning. Smart question, but that's exactly right. Yes. Good. So what I wanted to do is actually just do a full-blown practice problem. I have 4 of them, but I don't know that we're going to need 4. Hi. Okay. You gonna go give him some pointers? Nice. Okay, so let's do this one. And I'm gonna do with you basically what we're gonna do together right now is essentially the identical of what's going to be asked on your homework. So your homework assignment is going to ask you for 1, 2, 3, 4, 5 things. Every problem you have to do 5 things. So in order, the first thing you're going to be asked for is the common ratio. So when I look at this problem, I'm going to say R equals, and what is it? Times 4. So I'm just going to put R equals 4. So what I'm doing right now is basically just a mimic of today's work. So you can look at this as a resource and say, okay, so I got to do this and this. It's in the directions too. The next thing we have to do is find the next 3 terms. And so I can erase the dots now. And if you know that it's just times 4, because that's what R tells us to do, then I can just take 192 times 4, and I can figure out that the next term is 768. And then take that times 4, and I get 3,072. And then take that times 4, and I get 12,000. And I shouldn't use a comma, so I take back my comma. Yeah, so 12,288. Normally, not using commas makes math teachers cranky. So it's going to look weird if you use commas inside a comma.
Like 12,283. That's wrong.
Right, yeah. Okay, so far we've accomplished the first 2 tasks on the to-do list. We found R, done. We found the next 3 terms. The next thing we have to do is write the explicit formula. And so look at your notes that you just took and see if you can help me write an explicit formula for this one. You won't need a calculator for this, by the way. Not for the formula. In the formula will be later. So I just want the explicit formula, the one that has n's in it. So it's going to say A sub n equals what? A sub 1 Nice job. Now, of course, this is not any good for us. We're going to have to flip our pencils over because there are a couple of numbers that need to be put in place of letters, right? Like, do we know A sub 1?
Yes.
What is it? Okay, so in our formula where we put A sub 1, we really should have put 3. And do we know R?
4.
So where it said R, we really should have put 4. So understand that that's where those things go. So when I ask you to write an explicit formula, I'm asking you to write that. Does that make sense? Dallas, you good? Okay, good. That's it. So geometric explicit is super simple. It's what the number you start with times the multiplier raised to the power of n minus 1. Simple. All right, the next thing I'm going to ask you, or that the worksheet's going to ask you to do. So again, this one right here is called recursive. Excuse me, this one right here that we just wrote is called explicit. The next thing we're going to do is write recursive. And again, you're just going to use the notes that you took as a resource. And so I know it starts with a sub n. So a sub n equals what? Yep. And again, instead of putting times r, what should we put?
Times 4.
Good job, times 4. You can't replace a sub n minus 1 because we don't know what it is. Like, it doesn't make sense. I don't know what comes before any term because I don't know what the term is. But this is what the recursive formula would look like. Got it? So let me label these for you. So again, this first one is called the common ratio. You don't have to label it when you're doing your homework. I'm kind of being thorough so that you have something to look back at. So the common ratio, done. Explicit, done. Recursive. Oh, I did it again. I forgot part of the recursive. Of course it would. Yeah, it's twice in a row that I've just spazzed out. So you need the first term. Thank you for that. So the first term is, of course, 3. Well, I'm clearly a ding dong. So yeah, don't forget with your recursive, don't be like me. Don't forget that with your recursive, you need the formula, but you also need that freebie term. And again, as a general rule of thumb, we use the first term for a recursive. But like Dallas said, I mean, you could use another term. It's just more annoying for people. It's kind of rude, you know what I mean, to make them have to go through that. So the other thing that you have to do, I said you have to find 1, 2, yeah. So we found 4 things now. So item number 1 was up here. We found the common ratio. Item number 2, we filled in the next 3 terms. Item number 3, we did the explicit formula. Item number 4, we did the recursive formula. And then item number 5 is going to be to just find some random term. So every problem is going to ask you to find some random term. So let's find a sub 14, which it's going to be really, really big, right? I'm sure you understand that. So first off, which formula really ought we always use for finding specifics? Always explicit. Yeah. Yeah. Recursive has his place, but really we're going to get super efficient, immediate usefulness out of the explicit formula. So I'm going to take the number 14. I'm going to write this in yellow for you. The number 14 is going to go right there. And then into my calculator, I'm going to type 3 times 4 to the power of 13. Yes, because I had to do 14 minus 1 because it's built into the formula, right? So I'm going to go 3 times 4 to the power of 13. And it's massive. And that's, like I said, I mean, you're going to get some really big numbers today. So we're going to have 2, 0, 1, 3, 2, 6, 5, 9, 2. I'm going to pause this really quickly. So that all made sense? Okay. So I wanted to do one quick little side note and then one more problem with you because there's a little something different that can change. But again, this process right here, I'm going to ask you to do this on today's worksheet just over and over again. So another consideration is, as always, there might not be a geometric sequence. And so I know I've kind of already let the cat out of the bag, but if you saw something like, 5, 7, 9, 11, you might get excited, but really that's a days gone by. What is that sequence? That's it starts with the letter A. What are these called again? We just took a quiz on it. Arithmetic, right? So this is an arithmetic. So like if you encounter one of these on today's worksheet, make sure you understand that we have to be very specific. Another one that I wrote on my note card was like this. It's really easy to look at this and say, oh, now we're back to geometric. But again, you have to hold yourself massively accountable. To go from -4 to 8, what do you multiply by? It's not 2.
4.
Certainly not 4. How do you multiply a -4 to turn it into a positive 8? You multiply by -2. And how do you multiply to make an 8 into a 16? Regular 2. So you can see the discrepancy since we multiplied by different numbers.
I'm not the text is like 10, -20, 30, -40. How did I understand? That one I didn't get.
Well, that's because it's not arithmetic.
Well, yeah, I didn't do it. But like,
Good. Because that would be something actually that we're going to look at right now. So I want to do one more with you, and if you want to do two, I do have another one in the queue ready to go, but I'm going to pick this one. So our sequence is -2, 10, -50, 250, ... So your first job is to identify, is it geometric? Is it? You have to be able to ask yourself every single time, when I go from one term to the next, so from here to here,
No.
what do I multiply by? I multiply by -5. And I know it has to be times the negative because I'm switching it from a negative to a positive. What do I multiply by when I go from 10 to -50? Okay, so this is looking promising because I'm still multiplying by the same number, -5. What if I go from -50 to +250? So I can see now definitively this is a geometric sequence. And it's a little bit tricky. So this kind of goes to the one, Dallas, that you were asking about when it waffles back and forth from positive to negative, but that's okay because by definition, we're multiplying by the same number each time, right? Okay, so let's all agree, yes, this is geometric. And so if it's geometric, then we proceed with the directions. So step one says to find the common ratio. And so for my common ratio, I'm going to write R equals what?
-5.
Of course, -5. Yeah, it's written on the board 3 times, right? It's what we multiply by to get from one term to the next. The next step is going to ask us to fill in the next 3 terms of the sequence. So let's go ahead and do that. What comes after 250?
500.
So 250 times -5 is
-12.
-1,250. Good job. And then take that answer while it's on your screen and just hit times -5. And what do you get?
6,000.
250. Very good. And then take that while it's on your screen and hit times -5 again.
31,250.
Perfect. And then so on and so forth. So
How many
we
do we do?
just 3. So it'll say to find the next 3. Okay, the next thing on our to-do list is to write the explicit formula. And the explicit formula for this one is going to be A sub n equals what? Good job, Dallas. -2 times, and then what's the common ratio? Good job. So I'm going to put times, and then I do need to put this R value in parentheses because it's a negative. Okay, so take note of that when we do our explicit formula, any negatives, like, well, excuse me, this negative needs to be enclosed because it's going to have an exponent. No, it's because it's going to have an exponent.
Oh,
And its exponent is n-1. So whenever anything has an exponent, if it's a negative, the negative number has to go in parentheses. So great job on the explicit. Good job. And we didn't waste our time by saying A sub 1 and R. We actually just filled it in as we went, which was pretty dope. So the next thing we have to do is find the recursive formula. And the recursive formula says what? Times.
-5.
Good. And again, I'm going to use, thank you. Yes. So just continue to look back at your notes. Remember, we wrote down how to write a recursive formula. And the recursive formula basically just says any term is the term that came before it times whatever, in this case, -5. And then, yes, I need to be specific and then say that A sub 1 equals -2. So everything in this purple box is the recursive formula. So purple box is recursive. And then up here in the green box is explicit. Right, and so let's just pick something not too obnoxious. Let's say we want to find like the 11th term. So we want to find A sub 11. And no cheating, like you can't just take the 7 that you already know and then just cheat it 4 more times. So let's actually use the formula. So into our calculators, we're going to put the first term, -2, times the common difference, -5. Make sure you use parentheses. Not going to work if you don't. And then we need to raise it to the power of what?
10.
Good job, 10.
I got a real big.
It is going to be a large number, yeah. So we're going to do -2 times -5 to the power of 10. And it is massive.
193.
And it is negative, right? So it's going to be negative
195,312,000. Yeah.
I can say that when you read numbers that are big like this, and by the way, we can put commas in our answers because our answers aren't part of a list. And so when you do numbers that need commas, always start from the right side. And so always chunk from this right end over here and then just go 3, chunk, 3, chunk. And it makes the number make sense. And now we can obviously see it's negative 19 million change, whatever. Yeah, so that's it. That's the expectation. So to summarize, you need to be able to look at a sequence, determine if it's geometric. If it is, go through and do those 5 things. Find the common ratio, fill in the next 3 terms, find the explicit, find the recursive, and then name some random term. Well, not random, it's ASCII.
Jerry.
Huh? Yeah. Yeah. All right, then. That is that.